In lesson 7, we're trying to solve for x. Some of these problems will only require one step, some of them will require 2 or 3 steps. Where we begin is with two sides of the equation. Our goal is to get letters on one side, numbers on the other. So right now I see on the left-hand side of the equation are letters and numbers. On the right-hand side are just numbers. So I'm going to choose to take the numbers to the right-hand side and leave the letters on the left. That means what I need to move is this plus 9. In order to move that plus 9, I'm going to do minus 9 here. That way plus 9 and minus 9 will combine to give me 0, meaning there's no longer a 9 on that side. But what I do to the left side of the equation, I also have to do to the right side of the equation. So if minus 9 makes this go away and just give me x, I also have to do minus 9 on this side. So here these 9's go away, which was my original purpose. It leaves me with x. On this side, when I resolve 12 minus 9, I'm left with 3. And that is the correct final answer. X equals 3. Same idea in problem number 2. I need to get rid of this 1. To do it, I do minus 1 to both sides. These go away and just leave me with x. 5 minus 1 gives me 4. For problem number 3, it's the same general idea. It's a one-step problem. The only difference is instead of adding on the left, we're subtracting. So the opposite of subtraction is addition. That means in order to get rid of a negative 3, we're going to have to add 3 to both sides. Add 3 to the left, also add 3 to the right. Whenever I'm talking about left and right, I'm talking about this equal sign. This equal sign separates the problem into two sides. What I do on one side of the equal sign, I do to the other side of the equal sign. So here, these 3's go away. I'm just left with x. 8 plus 3 gives me 11. Same idea in problem 4. To get rid of that negative 6, I add 6 to both sides. That leaves me with just x equals 5 plus 6, which is 11. For problem number 5, here I want to begin by moving the 3. So it's a positive 3 now. I'm going to do negative 3. That's going to get rid of the number on the left and just leave me with 2x. On the right, 17 minus 3 leaves me with 14. The reason we're not done is because we don't have 1x on the left-hand side. We have 2x. So whenever we have something being multiplied by x, the way we're going to undo that is with division. So right now, this is really saying 2 times x equals 14. If 2 times x equals 14, then to get x by itself, we're going to have to divide by that number in front of the x. What we do to the left side, we have to do to the right side. So these 2's go away and just leave me with x. When I do 14 divided by 2, that gives me 7, which is the correct final answer. For problem number 6, I need to start by moving this 2. That's going to leave me with 3x equals 24. Then I divide by what's in front of the x. That leaves me with x equals 24 divided by 3, which is 8. In problem number 7, I don't want to move either the 2x or the 7x. Those are both x's, they're variables, they belong together. Really what I need to understand is that because these are like terms, they can be combined. 7x's and 2x's give me a total of 9x's. As opposed to the problem above, 3x plus 2, these were not like terms. If the 2 had an x, I could combine it with the 3, but I can't combine something with an x and something without an x. So back to where we were, we had 9x equals 18. If we divide by what's in front of the x, here we're left with just x. 18 divided by 9 gives me a final answer of 2. Same idea in problem 8. I'm going to start by combining the x's on the left-hand side. 3 plus 3 gives me a total of 6x. That equals 54. And when I divide both sides by 6, that leaves me with just x equals 54 divided by 6, which is 9. For problem number 9, I do have to combine the like terms like I did before, but I also have one unlike term that can't be combined. So I'm going to take this 4x and this 6x and combine them. That's going to give me a total of 10x. I still need this plus 2 because that plus 2 doesn't have an x with it and can't be combined with the things with x's. What I can do with that plus 2 is move it to the other side with a minus 2. That leaves me with 10x on the left and 30 on the right. When I then divide by what's in front of the x, I get the correct final answer of x equals 3. For the final problem here, I have both x's to combine and numbers to combine. I again need to keep them separate. So this x is an understood 1x. When I take 1x and combine it with 4x, I get a total of 5x. When I take positive 6 and combine it with positive 15, 6 plus 15 gives me 21. This still equals to 41. Wanting to only have letters on the left-hand side, I'm going to need to get rid of this positive 21. I do that with a negative 21 that I also have to do on the right-hand side. These go away and just leave me with 5x. On the right, 41 minus 21 leaves me with 20. Then I just need to do my last step, which is divide both sides by 5. That's how I get the final answer, x equals 4.